أعزائنا طلاب الصف الثاني الثانوي، بنرحب بكم في حلقة جديدة من برنامجكم تبسيط العلوم. معاكم النهاردة هنقدم درس جديد من دروس الاستاتكس، وده طبعا فرع مهم جدا من فروع الرياضيات. هنتكلم النهاردة عن ليسون 4، وهنقدم كل التفاصيل والمعلومات والمصطلحات والاكسبريشنز الخاصة بهذا الدرس، وشرح ومجموعة من التدريبات والتمرينات الجديدة. معانا ومعاكم النهاردة لتقديم هذا الشرح مستر عبد الناصر جابر، خبير الرياضيات لغات بوزارة التربية والتعليم. دايما ضيف عزيز علينا، مرحبا بك.
ربنا يخليك. اهلا وسهلا.
اهلا بيك يا مستر عبد الناصر. ونقول كده شرح مبسط كده، النهارده ان شاء الله هيكون الليسون 4 معانا في الاستاتكس، تقريبا ده هيكون الدرس الاخير في المنهج.
احنا مقسمينه جزئين، الايكوليبريم 1 والايكوليبريم 2.
تمام،
يبقى كده خلاص
ان شاء الله. طيب نقول بشكل كده سريع، الدرس النهارده بيتكلم عن ايه، او ايه اهم المصطلحات اللي ممكن يتعرف عليها الطالب في الدرس الجديد؟
تمام. احنا اتكلمنا في الدرس الاول عن resultant of two forces acting at a point. كان في two forces كده بيأثروا بوينت واحده، وكان بنجيب الريزلتنت بتاعهم ونلغيهم هما. بعد كده خدنا حاجه اسمها ريزوليوشن. الريزوليوشن دي بيبقى عندنا فورس بنلغيها ونعمل ريزوليوشن يعني في اتجاهين مختلفين. بعد كده النهارده ان شاء الله هندرس equilibrium of a body under the effect of two forces or three forces. Okay? Today we are going to study a new lesson which is equilibrium 1. Equilibrium part 1. This lesson divided into two parts. Okay, so equilibrium of a rigid body under the effect of coplanar forces meeting at a point. Equilibrium of a rigid body under the effect of two forces. We are here two forces. It's a body here put on a scale. Its weight equal 20 kilogram weight, and it has a reaction equal 20 kilogram weight also. So the weight effect downward and the reaction effect upward, and they are equal in magnitude and opposite in direction. So the equilibrium here, the body here is in equilibrium. Another example, we have a body suspended here with a string, and this string has a tension. The weight effect downward and the tension effect upward, they are equal in magnitude and opposite in direction. So the body here is in equilibrium. Yes. When we draw it, we draw a straight line like that. This is the body, and its weight equals 20 kilogram weight effect downwards, and the reaction or the tension effect upward, and its magnitude also equals 20 kilogram weight. So they are equal in magnitude and opposite in direction. So the body is in equilibrium. Terms of balancing a rigid body under the effect of two forces. A rigid body is balanced under the effect of two forces only if these two forces are. Yes, the same drawing here, we have a body has affected on two forces, one of them downward and the other upward. So it is depend on equal in magnitude, are opposite in direction. Their lines of action are on the same straight line, like that. Upward, downward, equal in magnitude, opposite in direction, and they have the same line of action. Example, we have here, he says that if a force of magnitude F is in equilibrium with two forces of magnitudes 5 Newton and 3 Newton act at a point and enclosed between them an angle of measure 60 degrees. Find the value of F. We have here a question, is a simple one, and we try to draw it. This is the solution. If we draw these two forces, we have here first force, which is equal 3 Newton, the second one, which is 5 Newton, and enclosed between them 60 degrees. So, if you want to find the resultant here to be equilibrium, we must find the magnitude of this force, and it is act on the opposite direction of these two forces. So we would like to find out the resultant. We can find the resultant of the two forces 5 and 3 Newton from the rule. R equals square root F1 power 2 plus F2 power 2 plus 2F1 F2 cosine alpha. And we will substitute. We have here F1 equal 5, so F power 2 equals 25 plus 9 plus 2 multiplied by 5 multiplied by 3 and cosine alpha, which is cosine 60. Here R equals square root 25 plus 9 plus 15 equals square root 49 equals 7 Newton. So resultant equal 7 Newton. Since the force F and the resultant of the two forces are in equilibrium, so F equals 7 Newton also. Transfer the point of action of a force to any point on its line of action. If a rigid body is in equilibrium under the effect of two forces, then we can transfer the point of action for any force to another point on its line of action without any impact on the equilibrium of the body. Yes, concentrate with me, my dear students. If we have here a force like that, acts here, okay, the weight acts downward, and we have a tension acts upward. If we consider the point of the action of the weight will be here, but we can consider it here or there. It's no problem about the point of action if it is on the same line of action. So it is right if we transfer this point, the point of action here, to transfer it on any point, but must be on the same straight line of action. Okay, concentrate with me again. We have here an example. The force 3, 4, and 5, we have here three forces, 3 Newton, 4 Newton, and 5 Newton, are in equilibrium, as in the opposite figure. Yes, find the measure of the angle between the two forces, 3 Newton and 5 Newton. We have here, my dear students, a force effect at this body, and its magnitude 5. We have another one, which is 3 Newton, and they effect on the point here, A, or the body A, and we have another one equals 4 Newton. And we would like to find alpha. Alpha is the angle between 5 Newton and 3 Newton. So, remember with me the rule. It is the first rule, which is we can find with it the resultant. The set of forces are in equilibrium. So the resultant of the two forces, 3 Newton and 5 Newton, is equilibrium with the force 4N. So 4N here considered as the resultant of them, and they effect on the opposite direction of this straight line, or the action line. So we have here the same question. If the measure of the angle between the two forces 3n and 5n is alpha, then by applicate this rule, r power 2 equal f1 power 2 plus f2 power 2 plus 2f1 f2 cosine alpha, and substitute by r equals 4, f1 equals 3, f2 equals 5, then we will get 16 equals 9 plus 25 plus 2 times 3 times 5 cosine alpha. So 30 cosine alpha equals negative 18. And pay attention for something for the equation here. Some people make a common fault or a common mistake. They add 9 with 25 with 2 times 3 times 5. No, it's wrong. But you have to add 9 to 25 only. Then you multiply 2 times 3 times 5 to be the coefficient of cosine alpha. So 30 cosine alpha equals negative 18, which is 16 minus 9 minus 25. We'll complete. Cosine alpha equal negative 3 over 5. So measure angle alpha equals 180 minus 53, 749, which is 126 degrees, 52 minutes and 11 seconds. You have to use your calculator. You press the buttons, shift cosine 3 over 5 as a positive, not negative. So the answer will be 53, 749. And because it's negative, and cosine negative in the second quadrant, you have to find the difference between 180 and 53, 749. The answer will be 126 degrees, 52 minutes and 11 seconds. Let's go to another thing. Equilibrium of a rigid body under the action of 3 coplanar forces meeting at a point. If we have a body affected by 3 forces and it will be in equilibrium, if it's possible to represent 3 coplanar forces meeting at a point by the side of triangle of directions taken in the same cyclic order, then the force will be in equilibrium. Okay, we have here 3 forces. We have F1 and F2 and F3. All of them intersect at a point. All of them affect of a body here. And we would like to draw a triangle, represent the 3 forces here. So in the opposite figure, the 3 forces will be in equilibrium if their magnitudes represent the size lengths of triangle taken in the same cyclic order. So triangle of force rule now. If we have F1 here, OA represents the fourth one, and OB represents F2, and we have the resultant here equals F1 plus F2, and this figure represents the 2 forces F1, F2 that act at a rigid body in direction OA and OB. The resultant of the 2 forces is F1 and F2, which act on the OC line, on the diagram OACB. But F3 equals in magnitude and opposite in direction to F1 plus F2. We know that F1 and F2, we can add them as 2 forces and find their resultant, which is F1 plus F2. And because of equilibrium, we can represent them by a third force, which is F3, but it affects in the opposite direction. So we have F3 here equal to resultant of F1 plus F2 here, opposite in direction and equal in magnitude. So the body put here is in equilibrium. So F1 plus F2 plus F3 equals 0. So if the body is in the effect of three forces, we can add the two forces into one resultant, and this resultant equal to the third force. And now they are only two forces, opposite in direction and equal in magnitude. Then their sum equals 0 because they are equilibrium, and vice versa. If F1 plus F2 plus F3 equals 0 vector, then they will be in equilibrium. Okay. We have here, to check your understanding, F2, F3, F1 can now represented on the sides of triangle, and concentrate here, you find them effect in cyclic order. This is direction, after it F2, after it F3. They act on the same direction, so it's in the same order or in the same cyclic order. Figure 2 represents the triangle of forces of three equilibrium coplanar forces F1, F2 and F3. When the lengths of sides of the triangle are in proportion with the magnitudes of the corresponding forces, we will apply this rule. This is the important and easy rule to find the unknown forces. If we have here F1 represented by the side length of triangle OA, and F2 represented by the side length of AC, and we have F3 represented by the side line OC, on the same order, we can apply the triangular rule, which is F1 over the length of AA equal F2 over the length of AC equals F3 over the length of CO. Example: a body of weight 12 Newton is hinged from one end on a light string whose length 130 centimeter. The other end is fixed at a point in the vertical wall. The body is pulled by a horizontal force which makes the body in equilibrium. It's important to say equilibrium. When it is at a distance 50 centimeter from the wall, find the magnitude of each of the force and the tension in the string. Pay attention to the drawing here. We have three forces. The body, its weight equal 12, as he said here. A body of weight 12 Newton. And the body always affect downward, vertically downward. And we have a force, this force pull the body outward, and we have string, so it has a tension here. So they are under the effect of the weight is in equilibrium under the effect of three forces. The horizontal force, which is F here, and the tension, this is the tension on the string, okay, and the triangle, we can find length of AC from the Pythagoras here, rule. We have here triangle represents these three forces, 12 downward, so we have 12 here, concentrate with me, F to the left, and we have horizontally F here to the left, and BA represents the tension of the string. So we have to find AB. The length of AB from Pythagoras theorem equals 120 power 2 plus 5 power 2 inside the square root. The answer will be 120 centimeter. Triangle ABC, the triangle of force. So when we applicate the rule, which triangular force, T here over 130. What is T here? Here T is the tension. We divide it over 130, which is the length of AB, equals 12, the weight, over AC, which is equal 120 centimeters, equals F, this force, this horizontal force, which affects the body, over the length of CB, which is 50. So T will be 13 Newton and F equals 5 Newton. How? If we multiply 12 by 130 here, cross multiplication, divided by 120, you will get T equals 13. And F, you must multiply 50 by 12 divided by 120, then the answer will be 5 Newton. Lam's rule. It's very important rule and easy rule to solve the equations or to find F1, F2 and F3. If the coplanar forces F1, F2 and F3 act at a point and equilibrium as in figure 1, look at this figure. We have here F1 acts on BC, F2 acts in CA, and F3 acts on AB. So these three forces act on the cyclic direction or cyclic order of triangle. And we have exterior angles here. Look carefully at this. Theta 1, which is opposite to F1, theta 2, which is opposite to F2, and theta 3, which is opposite to F3. And act at a point and equilibrium is in figure 1, then it could be represented by the sides of triangle taken in the same cyclic order as in figure. Using the sine rule. You know, my dear students, the sine rule. It is BC, which is the side, over sine the opposite angle, which is what? Which is 180 minus CT1. If you want to look at them carefully here, I have drawn this figure for you. F1 opposite to theta 1, F2 opposite to theta 2, F3 opposite to theta 3. So BC over sine 180 minus theta 1, which is this angle, equals CA over theta 2, which is 180 minus theta 2, which is its angle, this angle, and AB over sine 180 minus theta 3, which is this angle. Okay? So the final answer for this equal F1 over sine theta 1 equal F2 over sine theta 2 equal F3 over sine theta 3. In the figure, look carefully, it's easy for you to understand. We have here F1, make it divided by sine theta 1, not theta 1, not the angle, but sine the angle. It's very different. So F1 over sine theta 1 here, which is opposite to it, equal F2 over sine theta 2 equal F3 over sine theta 3. If a body is in equilibrium under the effect of three forces meeting at a point, then the magnitude of each force is proportional to the sine of the angle between the two other forces. We have an example here. Yes, three coplanar forces of magnitude 60 F and K Newton meeting at a point are in equilibrium if the measure of the angle between the line of action of first and second forces is 120 degrees and between the second and third 90 degrees. Find the value of each of the F and K. We have to draw. We have three forces here. X at a point, F the first force, and 60 the second, and the enclosed 120 degrees between them. We have 60 and K, the second and third forces, which is enclosed 150 degrees, and F and K enclosed 90 degrees. So, the system is in equilibrium under the effect of the following three forces. A force of magnitude 60 Newton, force of magnitude F and K Newton. By applying what, my dear students? Lamb's rule, which is easy rule for us. We get, if we divide 60 by sine 90, will be equal F over sine 150 will be equal K over sine 120. So, by using your calculator, you can find F by cross multiplication. Here, 60 equal to F equal to K over root 3, and F equals 30 Newton, and K equals 30 root 3 Newton.
جميل. مستر عبد الناصر، لامز رول كان اخر حاجه النهارده شرحناها وقدمناها في درسنا ليسون 4. بشكرك على وجودك معنا واطلاله جميله جدا النهارده على ليسون 4. شكرا يا مستر. شكرا حضرتك. وصلنا معاكم اعزائنا الطلاب لنهايه ليسون 4 في ماده الاستاتكس فرع رياضيات. حتى نلقاكم مجددا، دمتم في رعايه الله وامنه. شكرا.